Good morning, students. Let us continue with Chapter 9 Force and Laws of Motion. In the fifth session today, we will learn 1. The statements of third law of motion, 2. The concept of action and reaction, and 3. A few examples related to third law of motion. To begin with, let us have a look at this boy in the picture wearing roller skates. When the boy exerts a force on the wall by pushing it with his hands, then the wall exerts an equal force on the boy in the opposite direction, causing him to move backwards. Here we see that the man is exerting a force on the cow and the cow is exerting an equal and opposite force on the man. As both the bodies influence each other by applying force, we can say that they are interacting with each other. In such interactions, two forces will be there, and the relationship between these two forces are described by what we call Newton's third law of motion. The Newton's third law of motion states that when one object exerts a force on another object, the second object instantaneously exerts a force back on the first. The statement implies that these two forces are always equal in magnitude but opposite in direction. These forces act on different objects and moves on the same object. Let us consider two spring balances connected together as shown in the picture. The fixed end of balance B is attached to a rigid support such as a wall. When a force is applied through the free end of spring balance A, it is observed that both the spring balances show the same readings on their scales. This means that the force exerted by spring balance A on balance B is equal but opposite in direction to the force exerted by the balance B on balance A. Here, note that the force which balance A exerts on balance B is called the action, and the force of balance B on balance A is called the reaction. Here we find two cases: a box resting on the ground and a man walking on the ground. In the first case, the downward force exerted by the box on the ground is called action, and the equal upward force exerted by the ground on the box is called reaction. In the second case, the backward force exerted by the feet of the man on the ground is called action, and the forward force exerted by the ground on the feet of the man is called reaction. Action and reaction. The two opposing forces that are equal in magnitude but opposite in direction are known as action and reaction forces. Action. The force exerted by the first object on the second object is called action. Reaction. The force exerted by the second object on the first object is called reaction. Action and reaction always act on two different objects. Now, let us know more about action and reaction through these examples. Here in figure A, we find an inflated balloon released with its mouth in the downward direction. The downward force exerted by the balloon in the air is called the action, and the upward force exerted by the air on the balloon is called reaction. Likewise, the rocket in figure B also works on the principle of action and reaction. Here, hot gases are produced from rapid burning of fuel due to the downward force exerted by the rocket on the air. The gases in turn exert an equal and opposite force on the rocket, pushing it in the upward direction. Here we see a sailor who jumps out of the boat onto the bank of a river or a lake. The force exerted by the sailor on the boat, pushing it backwards, is the action, and the force exerted by the boat on the sailor, pushing him forward, is the reaction. So, the concept of action and reaction gives us an alternative statement of the third law of motion, which states that to every action there is an equal and opposite reaction. As the forces act on objects of different masses, the accelerations produced are not equal in magnitude. For example, when a gun is fired, it exerts a forward force on the bullet, and the bullet exerts an equal but opposite reaction force on the gun, causing the recoil of the gun. As the gun has a much greater mass than the bullet, the acceleration of the gun is much less than the acceleration of the bullet. In this picture, the woman exerts a force on the water by pushing it backwards with the oars. The water in turn exerts an equal and opposite force on the boat, pushing it forward. That's all for today, children. Thank you.